Recording in progress.
All right, guys, so let's get going here. So a zero matrix is exactly what you see. It's just a matrix with a bunch of zeros in it. So for example, this could be called a zero matrix. I don't know why I put A there. Let's just call it different letters. Call it C. Guys, quiet, please. So, wait, do you guys have your notes, Cooper and Rob?
No, I mean these.
Yeah, but your notes. It's the same notes, guys, from the whole week. Yeah, let's get the notes, guys. Come on. All right. Yeah. Okay. Anyway, so anyway, a zero matrix is just a matrix with a bunch of zeros, and that's all it is. So, and if you add a zero matrix to another matrix, it just the matrix stays the same. It's like if you add zero to a number, nothing changes, right? If two matrices add up to zero, then they'll equal its negative counterpart. So, for example, if matrix A is 1, 4, 1, 4, 3, negative 2, 1, 4, 3, negative 2, plus matrix B equals 0. What do you think matrix B is going to equal, guys? Yeah, negative 1, negative 4, negative 3, and 2. That's all. Because they cancel out. So there's nothing really special about it. We don't really actually do anything with it. It won't be a test question because it's too easy. But just so you know, a zero matrix is a matrix with a bunch of zeros. And if you add it to any other matrix, you get the original matrix, right? So that's all. And if two matrices add up to 0, then they're going to be negative counterparts of each other, right? If A plus B equals 0, B is a negative counterpart of A, A is a negative counterpart of B, blah, blah, blah. There we go. So we're good on that one? Cool. Take your time. No rush. You guys found your notes? Coop and Sarah? Good. All right, can I move, guys? All right, thanks. Oh. You good? Okay. And don't worry, guys, I'm recording this as well. And also while I'm at it, I will need my calculator. So let me pull it up while I'm here. Yeah, that's old stuff. I need to clean it up. It's like, yeah, actually, I don't know what's in there. No, I did terrible this year. Yeah, I had a lot of injuries. Basically, if you didn't have, oh yeah, I'll find out how that goes. Yeah, if you didn't have McCaffrey or Tyreek Hill, I mean, those are the two guys that did really well. You know what's crazy is that Lamar Jackson got 49 out of 50 first place votes. You know, no one called the MVP award. Call it the best player for weeks 13 through 17. Just call it that. Just call it what it is. It's not the whole season. Lamar Jackson was not the best player the whole season. I think it was if you look at the body of work, absolutely is a better. Or McCaffrey, sure. How did Dak Prescott?
Tyreek Hill, McCaffrey, or Purdy there? Because Lamar turns up late in the season.
Okay, he had a great game, I think, against was it Miami? I think no, well, against Miami, he also had a huge game against them, but. I don't know. Just call it for what it is. And it's kind of like when Andrew Luck didn't win the Heisman because Robert Griffin III had like a great November. It's like it's just stupid. Like it's.
He can't even win playoff.
Yeah, same with Cam Newton. He went over Andrew Luck, and he's not in the backup anymore. So it's a little bitterness, but that's all right.
Wait, did Cam Newton win a Super Bowl?
He got one.
Remember
when it was here.
Yeah.
He lost to Denver when it was hosted here. Cam Newton? No. Reggie Bush is yeah. Actually, I would even go as far as saying no. You guys are getting me off track, guys. We gotta get back to this. Sorry. But hold on. No, one play that comes to mind. Oh, Vince Young against USC and that Rumble. That was incredible. Vince Young was so good in that game. So anyway, yeah. All right. Well, let's go. Okay, next up, identity matrix. An identity matrix is a matrix that has a bunch of ones and a bunch of zeros. So an identity matrix looks like this. A bunch of ones along a diagonal going from top left to bottom right. a bunch of ones along a diagonal from top left to bottom right. Then filled with zeros. That's called an identity matrix. As you see to the left there, the 2x2 identity matrix, 3x3 identity matrix. It's also going to be what we call a square matrix, meaning the rows, the number of rows, equals number of columns. The number of rows equals the number of columns. So you're not gonna have a 2x3 identity matrix. You're not gonna have a 3x2 identity matrix. It's always gonna be 2x2, 3x3, 4x4, 5x5, and so forth. And it's a bunch of ones that go on a diagonal from top left to bottom right, and you fill the rest with zeros. Fill the rest with zeros. That's called an identity matrix. Now, what happens when you multiply something by an identity matrix? The identity does not change. So this is also very important too. Any matrix multiplied, any square matrix, let me take it back. Any square matrix multiplied to an identity will come out the same. Hence, its identity is preserved. I know it sounds kind of fancy. So any square matrix multiplied to an identity matrix will come out the same. Hence, its identity is preserved. So if I multiply A times I get A. Or I times A, I get A. Or if A times B equals I, this is gonna be a tricky one. We're gonna talk about it in a little bit. But if A times B equals I, then A equals the inverse of B. We'll talk about this on the next page. Really cool, the inverse of B. If two matrices multiply to an identity. But let's work out number 14 before I move on. And by the way, I am recording this. I also took a screenshot of this too. Actually, I think the screenshot might be on the notes I gave you guys. I think I don't know. Might be. I don't know. Or the extra word problem packet. Oh, Grace, you missed on this. These are extra word problem practice. Actually, no, I did put a screenshot of this. That's all right. Okay, let's keep moving, guys. So let's work out 14 so you can see this in action. And then we'll talk about inverse matrices on the next page, and then we'll work out some problems. So here's what we're gonna do, guys. We got A, which is this. And we got I, which is this. So there's A and there's I. Now, if you actually were to multiply this, how is it gonna look? So remember, multiply the first row with the first column. What happens when you do that? What do you get? 1 times 1 plus 4 times 0, which is 1 times 1 plus 4 times 0, which is what, guys? 1. Perfect. Next up, multiply the first row with the second column. 1 times 0 plus 4 times 1. What do you get now? 4. Looks like we're preserving this identity. Let's do the second row with the first column. 3 times 1 plus negative 2 times 0. What do you get? 3. Lastly, second row with the second column. 3 times 0 plus negative 2 times 1. You get negative 2. Was this identity preserved? Absolutely. So this is just like multiplying any number by 1. right? Like what if I did 2.76 times 1? What do you get? 2.76, right? It's the same thing. In fact, actually, that's called an identity property. You might remember in geometry, you talk about all these properties like reflexive and addition property of equality. I know probably you guys are traumatized, like Kelly, like you look a little traumatized, right? Yeah, it's one of those properties. It's called an identity property. You're maintaining its identity. What if I reversed it? Okay, let's reverse it. Same thing. This is one of the rare cases where reversing the order of multiplication doesn't matter. Usually it does matter. Won't here. Won't here at all. First row, first column. 1 times 1 plus 0 times 3. 1 times 4 plus 0 times -2. So I still get 1. I still get 4. And then, and this is the beauty about having a video, because I think the notes sometimes can be a little confusing because you don't know the steps. So I highly I highly suggest to you guys, follow my words, that when you study for this test, a good way to study, seriously, is watch the video. I think back like 20 some years ago, I was a grad student at Stanford. I was studying engineering, and this is before YouTube. But I was taking a class with the dean of engineering because he was special because he's the dean of engineering. He had his lessons recorded, and I would actually go to the library at the engineering building and I actually would watch his recordings. It was really hard stuff. I can't remember what it was anymore. So something on semiconductor physics. I can't remember anymore. But anyway, I would rewatch his video, and that would help me on the exams because I had to rewatch it because I couldn't understand my notes. My notes didn't make sense because I took all this notes down, but there was so much dense information. This is dense information. I suggest maybe on Monday or Tuesday. This weekend is busy Super Bowl, but on Monday or Tuesday, maybe rewatch this video. I'll put it to school agenda, the homework assignment. Rewatch the video to see the process. I think that'll help you guys. It's a good resource. You should use it. So I'll get off my soapbox now. So 0 times 1 plus 1 times 3, you get 3. And then lastly, 0 times 4 plus 1 times -2, you get -2. So yeah, you can see that any matrix times its identity maintains its identity. This is a very important point for what we're going to do next. What we're going to do next is going to explain why that trick in the calculator. Remember I showed you guys last week how to solve crazy equations. Just do a matrix. Now you know what a matrix is. Raise it to -1 power. Like why -1 power? And why did it work? Now you're going to know why it works. Now you'll know why, which we're going to talk about now. But the identity matrix plays a role in that. So now let's move on to this part. What is an inverse matrix? Now, an inverse matrix looks like this. Let's say A, and actually I'm going to cross this off because it's not what I really want to write. Let's say A is this, just being hypothetical. Then the inverse matrix looks like this. It's really weird. Bear with me, guys. It looks really weird. I know. It looks strange. You do this thing, and there's a term for this. This is called the determinant. We're not going to go down that path. We're just scratching the surface, guys. Like there's a whole college course dedicated to just learning about matrices. Some of you guys might, if you're familiar with like Python or coding, you guys heard of machine learning. Like that's a term that's thrown around a lot. Machine learning is heavy on matrices, incredibly heavy, incredibly heavy. So there's a college course just dedicated to this. Actually, it's called linear algebra, which sounds really simple. It's probably one of the hardest math classes you ever take. So this is yet another thing that we'll see, but we're not gonna ask you guys to do this because it's just a little weird. But you do this thing here. It's called the determinant, AD minus BC. Just do it, and then you have to swap these two and then make these negative. But the calculator can do it for you. So I don't expect you guys to do this by hand. I just want to show you how it looks. So let's say A is this, right? What was A in the previous example? Okay, let's use that. Okay, so 1, 4. That was a 3, -2. Okay. Let's say A is that. Then what's the inverse going to be? I'm going to do 1 over AD, which is 1 times -2, minus BC, which is going to be 4 times 3, times, I'm going to swap A and D and negate B and C. What does that become, that denominator on the outside? What does that become? What is that, guys? 1 over what? -14. So it becomes 1/7, 2/7, 3/14, -1/14. Okay. Again, I'm not going to ask you to do this on the test. You can use your calculator instead. Let me show you doing the calculator. Here's how you do in the calculator. You go math, zoom, you have 2 by 2, 1, 4, 3, -2, raised to -1 power, and convert that to a fraction, math frac. There you go. Yeah, you just type in the matrix like you usually do, right? You know how to do that? Alpha zoom. After you type it in, just raise it to -1 power, which you've done before also, right? And that's it. That's what you do. And then to convert to a fraction, you hit math frac. So I'll do it again one more time, guys, so you can follow along. Alpha zoom, 2 by 2 matrix. Type in the matrix 1, 4, 3, -2. Raise to -1 power. Hit enter. If you want to see fraction instead, hit math frac. That's the first option. And it gives you a fraction form. So that's called the inverse. Now, what if I multiplied A by its inverse? So A is this, right? 1, 4, 3, -2. And the inverse is this. 1/7, 2/7, 3/14, -1/14. All right, multiply this row with this column. That's 4/7 plus, if you reduce it, it'll be plus, hold on a sec. Oh, sorry, 1/7. That was dumb. Sorry, guys. 1/7 plus 6/7. Next up, I'll have 2/7 minus 2/7. And if I do 3/7 minus 3/7, because you get 6/14, which is 3/7. And then lastly, 6/7 plus 1/7. 1, 0, 0, 1. If you actually were to multiply these out, I know it's kind of messy with fractions, but I did some reduction, by the way. 4 times 3/14 is 12/14, that's 6/7, right? Or 3 times 2 is 6, well, 6/7. But -2 times -1/14 is 2/14, that's 1/7. So when you work it out, it comes back to the identity. So whenever you multiply a matrix by its inverse, you get the identity. This will be the same thing. This one, it's gonna be the same. I'm not gonna do it in interest of time. You get the same thing if you reversed it. It doesn't matter. So bottom line is this. Let me put it up here. Let's go like dark blue. Any matrix times its inverse gives you the identity matrix. Okay, that's always going to be true. Always, always, always. Okay, any matrix times inverse will give you the identity matrix. And reverse it, whoop-de-doo. Same thing. If I reverse, I still get the same thing. Okay. Now, this is the reason why this technique works. Why can we use an inverse matrix to solve a system of equations? This is the big moment. Kind of clear? All right. All right, so let's solve this. Now, on our test, I'll probably ask a question like this. And I'll probably put step by step. And this is exactly what I want you guys to show. You don't have to be super detailed because now you kind of know what's happening. But here's what's happening. You're going to put this as a matrix equation like this. So this is a matrix equation I'm doing right now. 19, -7, 2, -3, 1, 4, x, y. Make sense? And it works because what if you multiply this row by this column? Yes, so that's what has to be y. Great. So when you multiply this row by this column, 1x plus 4y equals 97. Great. It makes sense because if you were to multiply 2, -3, 1, 4 x, y, you get 2x minus 3y and x plus 4y. These are the same. They're the same thing. All right. Now find the inverse in our calculator. So I'm just going to use a calculator at this point. I know I should have to do it by hand. Seriously, just use the calculator. So alpha zoom, 2 by 2, 2, -3, 1, 4, raised to -1. Let's change it to a fraction. Here we go. Okay. So here's what's going to happen, guys. This is very, very important. This is why this technique works. What you're going to do okay, multiply both sides of the matrix equation by the inverse matrix. So you're going to do this. I'm going to be a little lazy here. Okay. You guys see what I just did? I know I moved it, but whatever I got, step 1, I copied it down here. That's quiet, please. I moved. So I moved. I multiplied each side by the inverse matrix, which I really agree. So I multiply the left of what I had up here, right? I moved it down here, obviously. I've multiplied the left of it by the screen and the left of this by the screen. What's going to happen? Let me circle some blue. What's going to happen with these two things here? When I multiply those two together, the inverse by its original, what's going to happen? What's it going to be? 1, 0, 0, 1. Exactly. Thank you, Grace. Yes. Yes. And the other side, I just got to work it out. If I work it out, I'll use my calculator here. If I work it out, I'm going to multiply that inverse matrix. Let me clear some stuff because it's not getting really busy. I'm going to multiply it to 19 negative 7. So alpha zoom, alpha zoom, a 2 by 1. Cool. 19 negative 7. You get 5 negative 3. And anything times as identity is the same thing. So therefore, xy, guys, quiet please, or x equals 5 and y equals negative 3. That's why this works. Because what you do is you multiply both sides by the inverse, you knock out this coefficient matrix that you got from coefficients of your equations. It gets knocked out, it gets undone, isolating x and y, and whatever's on the other side equals x and y. So it's kind of like solving a normal equation. Like for example, back in the day when you guys were learning about Algebra 1, right? Like you guys were, this is no different than this kind of situation. You don't have to write this down, but like when you guys said 2x plus 4 equals 10, how would you solve for x? What would you do, guys? Subtract the 4, right? And what you do is your next step. Divide 2, right? It's the same exact thing. You're trying to solve for a variable coefficient, you're dividing both sides. It's kind of dividing. But technically what's happening, and multiplied by the inverse, these become the identity matrix, this becomes some other jump, and the identity matrix becomes xy is xy. That's why this works. We're going to do this in a more streamlined way in the next example, but I want to make sure you guys at least see why the mechanism behind it. Now you have a video, so you can watch it if you want. That's the mechanism behind it. And it's very analogous to this here. Just a normal equation where you have to isolate x. It's the same exact thing, but you're doing some sort of matrix operation to make that happen. So x equals 5, y equals negative 3, right? Okay, I'm going to do this more quickly. And the way I'm going to do the next example is the way I want you guys doing the test. Because I want you don't have to be this detailed. I was incredibly detailed in that last example. You don't have to be that detailed for this next example. So if I ask you to solve this using a matrix, here's what I want to see. So how to do on our test. Here's what you do, guys. 2, negative 1, negative 3, 1, 2, negative 5, negative 1, negative 3, there's no z, 0. X, Y, Z, X, Y, Z equals 5, 11, and 10. Then you're going to do this, X, Y, Z 2, negative 1, negative 3, 1, 2, 5, negative 1, negative 1, negative 3, 0, raised to negative 1 power, 5, negative 11, 10. And then you just punch in the calculator. That's what you need to show. Write the matrix equation, isolate this matrix here, the x, y, and variable matrix. In fact, actually, let's label this. I'm going to call this the coefficient matrix. I'm going to call this the variable matrix. I'm going to call this the constant matrix. Okay. Now, I'm going to punch in the calculator to get my answer. Here we go, guys. Do it by hand?
Put them just straight into the matrix. How do I know when he's that or when he's this?
That's exactly what I'm doing. I'm putting it straight in the matrix.
Like we weren't doing the
You know
inverse.
this extra on X, Y, Z.
No, we are doing the inverse.
No, I know, but like stuff on the
The
quiz,
little negative one.
like on the back page of the quiz where I had the 3 equations.
Yeah, you had to do the inverse to solve it. That's exactly it.
But why does it seem so much more complicated?
This one? No, I'm just showing the detailed steps, like why it works. I just went straight to like the solution. But I'm showing you why this works. I'm showing the mechanism behind it. That's what's a little more complicated. I'm showing the nuts and bolts now. I just showed you the last step last week. So yeah, of course it's a little more because I'm showing more what's under the hood, right? Anyway, let me punch it. Let me clear my screen for a moment. Let me punch in the matrices. So alpha, zoom. Hold on. Alpha zoom. We have a 3 by 3, right? So you're gonna have 2. No, what's going on here? 2, -1, -3, 1, 2, -5, -1, -3, 0, raised to -1 power. Alpha zoom. So Grace, this is what I showed you guys. I just showed you like the last step, but I want you to show me the setup. That's what that's the only difference. That's all. Don't overcomplicate it. Hit enter and you'll get the answer. There you go. So 2, -4, 1. Now let me undo my erasings. 2, -4, and 1. And that's your answer. And it makes sense. If you were plugging back in each equation, it would actually work itself out. It works itself out incredibly nicely. Okay, we're cool. That's what you have to show me. This is enough work to show me. But technically what's happening
is you are multiplying each side by the inverse. And then you have to show that you have an identity matrix, and then the XY times the is XYZ, then whatever this is with XYZ. Now, to do this one by hand, by the way, is an incredible pain in the ass. I'm not going to show you guys. It's just by hand.
a 3 by 3 inverse is really hard to do by hand. Use your calculator.
So on like the test law, this is where one to do by hand.
Inverse, I'm not going to ask you guys to do inverse at all by hand. I mean, I used to have my students do the inverse of a 2 by 2, but I just don't care to do that anymore. An honors class, maybe I would, just because I want to challenge them, but I think it's just too much.
Okay.
So, all right. Okay, let's try a word problem here, guys, and then we'll wrap it up. Okay, here we go. You guys quiet, please. Thanks. All right. Here's what I'd do for you guys. For the write a verbal model, I think that's kind of dumb. I'm just going to say assign your variables. Know what your variables represent. Before you do any word problem, I think that's why some people struggle with word problems, because they don't do this. You got to do this. But you know what? I'll do it for you guys. I'll assign variables for you guys. I'll like on the quiz. Let X be this, let Y be this, let Z be this. I'll do that for you guys, just to avoid confusion. If you think about what are the things I don't know in this problem? If you read through it, what am I trying to figure out? What does the question want? It wants what, guys? Look at the last sentence. The cost of each item. How many items am I talking about? 3. And what are the items? So cost of a movie pass will be my first variable. So X will be the cost of a movie pass. I don't know what movies cost these days. Maybe 15, 20 bucks, who knows? What's Y going to be? Cost of what? Cost of packaged popcorn that you throw in the microwave. And what I'm going to Z equal? Cost of what? Just one DVD. Cost of a DVD. Cool. Now let's write the equations. And when you write the equations, I promise you this, every sentence will be an equation. 1, 2, 3. So 1, 2, 3. 1, 2, 3. Please give me the first equation. What would you say? Perfect. Next equation. Thank you, Kelly. And last equation. Thank you again, Kelly. Perfect. 72.5. And I'll put it as parts like this. I'll say part 1, part 2, part 3, like or part A, part B, parts. I'll do it like this, so it's easy for you guys, right? So now let's write the matrix equation. 2, 1, 0. 2, 2, 1. 4, 3, 2. You guys know this now, right? X, Y, Z. $15.5, 37, and 72.5. Cool. Okay. Use your calculator to solve. You guys can do this now, right? This is why I'm so keen on you guys learning matrices, because I don't want you guys doing this by hand
Every single time. But if parts tests with like 7 problems like this, there's no way you guys finish it out. It's just, or you guys can go crazy because you're gonna make some tests mistake. What I care about is, can you interpret the information correctly, and can you use technology to get you the answer? That's what I care about. That's how, honestly, that's how real life works in the STEM world.
you understand the problem, then use technology to solve it. You don't, yes, I want you to do one of these by hand so you understand the nuts and bolts, but you don't do this by hand over and over again. We be efficient, use technology that's out there, right? So let's use the technology that's out there. So alpha, zoom, let me clear my screen for a moment. I have a 3 by 3, right? What I got 2, 1. Then what was it again? It was 2, 2, 1. And the last one was 4, 3, 2. Thanks so much. Raise it to 1 power. Alpha zoom. And it literally just takes a minute. Like, just be patient. And then what was it 15.5, 37, 72.5. And by the way, the numbers should come out I mean, it could be decimals because you're doing cost. Now, what if X, Y, Z represent like the number of DVDs or the number of movie paths? And there has to be a whole number, right? So it can't be negative or decimal. So be mindful of the context. That's very important. And there we go. So X is 7, Y is 1.5, and Z is 20. So it costs $7 per movie pass, $1.50 for packaged popcorn, and $20 for a DVD. So this is the advantage of matrices. You can solve systems more efficiently in this manner. Okay. And the last one, and then we're done for today. And it was a long lesson, guys. I apologize. I wish I could give you guys time to work on homework because it's the Super Bowl, but just do it tonight or tomorrow, early Sunday morning. So the standard form of a quadratic equation, you guys know is this, right? And then create your equations. That's easy. -1 equals 4a plus 2b plus c. -6 equals a plus b plus c. And lastly, -3 equals 16a plus 4b plus c. Make your matrix equation, easy peasy. 4, 2, 1, 1, 1, 1, 16, 4, 1. A, B, C. And then solve it. I'm just gonna do it one more time. When I did 4 squared, right? The quad form. So 4, 2, 1, 1, 1, 1, 16, 4, 1. Raised to no 1 power. Alpha zoom. -1, -6, -3. Do it. And you get that. Make sure I do it all right. Yeah. -2, 11, -15. So equation of y equals -2x squared minus 11x plus 15. Hold on. Did I make a mistake somewhere? I think I made a mistake. Hold on. 4 2b plus c, a plus b plus c. Something seems a little fishy here. Guess what I did wrong? Some seems off here. Hold on. Let me make sure I punch in correctly in the calculator.
So I think it's a positive 11 negative.
Oh, you're right. -2, 11, 15. I copied the answer wrong. My bad. Thanks, Kelly. There we go. Yeah, that looks better now. Yeah, I feel better about that. There we go. And by the way, if you wanted to, you could go on to stat. I mean, depends what I ask you to do, but like 2, 1, and 4. -1, -6, and -3. Stat, calc, option 5, calculate. You get the same thing. So you can do that too. All right, we're all set. The notes are all done. Perfect timing.